today we are going to go into one more live session, and welcome to Coders Arcade. First of all, welcome to a new live session, new day, new live session. We are going to continue our DSA placement series, and last time when we covered the DSA placement series, we talked about stacks data structure. Today let us continue that part and let us continue with queues data structure. So let us start. So I'll just and there we go. I just was opening up. So now let us continue, guys. So today we are going to talk about a data structure which is very important for us. At the same time, it is a very basic data structure, or the starting data structure, which you will usually go ahead and learn when you start with DSA. And this has to be covered before only, because later on in advanced data structures these things are going to get thoroughly used and we should know about them, and this is your queues data structure. So in the last time, guys, I have explained you about what is your stack data structure. Well, queue data structure also very much is similar to the last data structure that we have studied, and that was stacks. So let us talk about that right here and let us continue, let us start. So today we are going to learn about queues data structure. Queue data structure. What exactly is a queue data structure? Queue data structure is a linear data structure. Okay, it is a type of a linear data structure, and what do we know about here in this queue data structure is that it is the concept, it is the data structure where the concept of first in and first out gets implemented. Now if you have not if you don't know what is first in, first out and first in, last out, let me just explain you. In the last live session also we have done this first in, last out, we have done it, where we were talking about stacks. So when we were talking about stacks, we were talking about that stack data structure, they implement the first in and last out concept, where the stack looks like very similar to like this box, where it is closed from beneath, and whenever a data is put right here, let's say this is your data, and as soon as you enter something, that data goes down there at the very bottom of the stack. And let's say you have included much more data here, data gets stacked over each other in the stack data structure. But because the stack was closed from beneath, it was the first element which you have entered, which was this white element, will get to out in the last, where in this case the concept implements FIFO, first in, last out. So this was the concept that we have studied in the last session, where the element which went first will be the last element to come out of the stack, and this was first in, last out. But in today's concept we are going to talk about the concept of first in, first out, basically. So what exactly is first in, first out? Now unlike you had seen queues data, the stack data structures, where the element is placed in the very end or the last or the bottommost area of the stack, it is closed from beneath, so it gets stuck down there. But in this case queue is open from both the sides. A queue data structure looks like this. So basically, if I tell you about this more precisely, if I just this is how your queue data structure would look like. Okay, where let us say that this is your data entering. I said this is the data which is getting entering, which is entering right here. Stack is, the queue is not closed from beneath. So what happens is that this area is still open. You said I'm gonna implement some more data onto it. Yes, in queues also the data is stacked over each other, but queue is not closed from beneath. It is open from beneath, and because of this, the very first element that came in is going to be the first element to go out. So we say first in and first out, like this. So this is how the concept of first in and first out is implemented. So basically I'll write here properly, first in, first out. Got my point? This is a very important data structure. Why so? Later on, this data structure is used very popularly in some other advanced data structures. For example, you say heap, or you say trees, or you say graphs. Well, the concept of FIFO, first in first out, is very much used in other data structures in future. So for us it is very important for us to know and use. Well, if you ask where in heap data structure we create priority queues, and well, that's a type of a queue itself which implements the concept of first in and first out. In trees we perform BST and BT binary trees, BFS, breadth first search traversal. In breadth first search traversals, we use the concept of first in and first out, and that is basically your queues. Got my point? Then comes your graphs. In all your graph algorithms, even in BFS or DFS, we use queues. BFS, it is very much popularly used. Then it is used in all the graph algorithms, graph algos. For example, Dijkstra's algorithm, Prim's algorithm, Kruskal's algorithm, Bellman-Ford algorithms, Khan's algorithm, topological sort algorithm, all of these algorithms, they use the concept of first in and first out. This is the importance of the concept of first in and first out, which is implemented. Basically, it is a queue. We understood that queue is open from beneath, and the element which entered first will be the first element to leave, and in this case, this is how it is implemented. Are you getting my point? So this is how it is done, guys. Now this is about the theory part that I have told you, but how would you implement this properly in your code, in your program? To implement this into your program, we can implement the concept of queues into various different styles. You can implement the queue from using arrays, the very basic collection that you have, arrays, or you can use the concept of linked list to implement the priority queues. So these are the ways that you can implement, and there are some extra ways as well. Today we are going to talk about the implementation of queues using arrays. So we need to understand how arrays can be used to implement a queue, or the concept of first in, first out. This is my question, and how to do that, let us see right here. Well, I hope so that all of this concept is very much clear to all of you. In here we will be using C++, as we have already understood previously, and we have understood about this before also, that we are going to do C++ data structures. All your DSA part will be done in C++, and queue will be implemented in this. So let us start and understand about how it works. So now the very first thing that you need to understand about how it works is how would you use an array? My first question is, how would you use arrays to implement a queue? It is simple. We will use two variables, one array, and that's all what you require here. Two variables, we will have the concept of front and back, and one array where we will apply DMA and dynamically allocate the memory. It will be a pointer. You got my point? So our array will look like this. Let us say this is our array. There we go, we have created, and I said this is zero base indexing. Of course, array has zero base indexing. Now, if you remember in the last concept, in the live session, we have discussed about how stack is implemented using an array. And there in arrays, and when the stack was created, we were using the top variable. But in here, we don't use top variable, we will be using our front and back variable. So let us talk about that. Example, you have an array. This is your array, and right now array is empty. How will you denote that array is empty? There will be two variables. One is front and another is back. They both will be pointing towards initially at -1. So we have this condition that if front and back are equals to -1, that means the queue or array is empty. Alright. So here we have this front and back. My question is how to implement first in, first out. This is the thing. We are trying to implement the concept of first in and first out. So let us talk about that. So this we have understood that front and back is equals to -1 initially will be there, and we will be setting it through the constructor. So we can basically what we can do is we can create a class. We can create a class called as queues. We can create a class called as queues, and inside this class I can say we have a int star ARR. This is a pointer which will be representing the array. Later on I am gonna dynamically allocate the memory just like how we did it in the stack data structure, and then we will be implementing that here. So I said int star ARR, and we will have two variables which is going to be int front equals to -1, and basically we will do that later on, and int back. Initialization we can do later on in the constructor of this class queues, where I can define a constructor and I can say ARR dynamically allocation of the memory into the ARR pointer, then front and the back will also be later on initialized with -1, and then this way our requirement is created. I hope so that till here it is very much clear. Now after this is done, I am just going to rub this part out. just going to rub this part out so it is much more clear. Let's say I have front and back to -1, and then when front and back is at -1, let's do one thing. I'm going to put some variable inside. I'm going to put some data here. So if I say that I want to put some data right here, data will not be directly entered like that. It will be entered using the back. So basically what I'm going to do is, I am going to say back, you move by 1. So basically back plus plus, and then front you also move for the first time right here. So both the back and front, they both are in the same spot, in the same place. Right? So basically they both are in the same place. Now from now on, if I want to write the code for this, what I can do is I can just say back plus plus, and then I can say ARR of back equals to some value, or this may be x, whatever. We will write a function. We will write a function of enqueue or push. So equals to val we will say. Okay. And then I will say front plus plus. But there is one catch here, guys. If I say front plus plus, how will I implement the concept of first in and first out? You see, I'm going to pause this here. I'm just going to pause this here. I'm going to talk about this very soon. Let's say if I want to implement another element right here. Let's say this is my next element. In that case, what will happen is that back will again move further. But now this time, front will not move. Front will remain at that particular place. If front moves, then what will happen? This element gets deleted. This is how you implement the concept of first in, first out. Are you getting my point? The idea here is that we are moving back plus plus, so that I can do the push or enqueue in the queues, and if I want to do pop or delete, I will say front plus plus again. So basically front plus plus is deleting the element. When front plus plus is deleting the element, you see for yourself, this was the first element which got entered. This was the first element which got entered. I'll write it with black. This was the first element which got entered, and this was the second element which got entered. And if I say front plus plus, what will happen? Let's take one more scenario where one more element is pushed, when this is the third element, and back has moved one more place right here, back plus plus, and ARR of back, we are saying that we have back plus plus, and we are saying that on this ARR, I am saying this is the third element. Okay, first element, second element, and this is third element. Okay. In this case, front will stay at the first position, holding that first element which is inputted. This is the first element, this is the second element, this is the third element. Remember, this is the first element which was entered, and this should be the first element which will leave the array. And to do that, what I can do? I can say front plus plus, and this element got deleted. So here, with the help of this concept, with the help of this front concept, I was able to delete that one. So the element which got entered in the first left the array first. Now the concept of first in and first out is implemented. Very easy. This is how we will do it. I hope so that this is very much clear, right? So how you will write the code for this? I told you this concept, logic understood, but how would you write the code for it? To write the code for it, it is very simple. Let us talk about how we will write the code. What happens when we do push? Let's say this is the push function which I am creating, and push function has some x variable as the parameter, that this element you have to push. Okay. So I send back plus plus, and before I do anything like that, I need to make sure that the queue is not filled. If the queue is filled, then it is overflow, queue overflow, or the array is already filled. So I will check if, and when that condition will be possible, when back is at -1. This is n-1 position, right? So if this is the size, if the size of the array is n, then if back is at n-1, that means no more elements to be pushed. So if back is equals to n-1, means if the back is already at the back of the array, it is full. So I can say in this case overflow condition. Then I said back plus plus. So this is only going to get executed if that condition is met, otherwise back plus plus, and then ARR of back is equals to, or not equals to, just equals to, I will put this x. Okay. With this I can implement the first element inside this array. I hope so that this is very much clear. After that I need to move front also, but I need to make sure that front is moved only once. It should not move again if I do again push, because if this function is called, it will push. If I say here front plus plus, then with every push front plus plus will happen and every element will get deleted. So what I need to do is I need to check for the condition. If front is equals to, or if front is not equals to -1, if front is equals to -1, actually, yeah, equals to, if front is equals to -1, then in that case just do front plus plus. Well, I hope so that this is very much clear, and this is your push function that we will do. If I want to say pop is very simple. In pop we don't pass any parameter. I can just say top, so there is no top, I can just say front plus plus, and there you go, front moved further and it got pop. This way I implemented the concept of FIFO, first in first out. Understood? So let us write this, but just not only push or pop, we have a peek function also, which is very important in terms of queues, to peek on which element is going to get deleted. In this case it will be front, so I can just say return ARR of front. This is gonna be your peek function, and this is how we are gonna implement queues in C++. Let us go and see the code. We will go ahead and see the code. So guys, here you have So we are starting with the first thing first, hash include IO stream using namespace S3 as usual. This is very common, this is usual. After that, we have created a class called as queues, and we have created an array pointer, and then we have taken int front and int back, as we already have discussed what is in front and back. And then I said in the public section of the class, I created the constructor where I have initialized the array using the dynamic memory allocation. How did I do that? I created the macro substitution and I used that to dynamically allocate the memory. This I have already explained you in the previous live session. So for those people who don't know, I am basically using the new keyword to allocate the memory. If this was C programming, you would have done using malloc function, and you might have been using typecasting. You might have done, of course, typecasting for that reason, but here we don't do typecasting because we are just directly using that as int. And then I said we have front and back set to -1 because initially it will be -1, which means no elements. Then I said we have a function called as here white push, where it is taking up one parameter x, and later on we are checking if the element is if the queue is overflown or not. In that condition is if back is equals to n -1, and then we said that queue is overflown and return. And what did I said? We will do back plus plus, and using back we will push the element, and here we are doing that. So back plus plus and ARR of back equals to x. This way I was able to do it. And front also has to be moved to the +1 position, right? So I said if a front is equals to -1, then only use front plus plus, because of course you don't want your front of the array to be implemented again and again, because if it does, it will delete the memory, it will delete the element or the data. And then I said we say pop. For pop, I did not tell you in the logic that we have to check for underflow condition. Underflow means if the array is already empty, what do you do? What do you pop? What do you delete? In that case, there are two cases, guys. If front is at -1, that means no element to delete, or if the front is greater than the back. If the front is greater than the back, that means there is no element. The queue is empty. I hope so that this is very much clear. And we have said front plus plus. Front plus plus is the logic to delete and pop. These two are the major functions that you need to understand in this case. And then we have peak. Of course, for peak also, if there is no element in the array, that means if the array is getting underflown, in that case there is no element. But here in this case, because peak will return integer type, I said return -1, rather than in other cases I am just not returning anything. You got my point? And then I am just saying return ARR of front, which is going to get deleted. Of course, this is going to be the thing. And then at last, this is also a part of the queue, which is the pool function. I am checking again if it is empty or not. So I will just want to satisfy the underflow condition in this case, and I have taken this underflow condition. If that is the thing, then return the true, and the function return type is boolean. Otherwise you say return false, and that's it. This is your queue data structure. In the main function, you can see we have created the object of queue because it is an object oriented program that we are writing. And using push function, I am pushing all the elements, and then later on I am peeking and pop, peek pop, peek pop, until the queue is clearly empty and it prints that underflown. Let us run this and see how it works. So there you go, guys. This is your output. It will come up. There you go. So basically 1, 2, 3, 4 got pushed and then pop. We have done. This is how you will do queues data structure. I hope so that this is very much clear to all of you, and this is how you do it. Well, I hope so nobody has any doubts into this, because this is a very basic data structure to understand. And well, that's all for today's class. This was your queue data structure, and this is enough for today's live session. let us talk about another data structure. Probably we will start with either linked list or priority queues, maybe we will do later on. We will first do linked list and then we will come back to stacks and queues to do stacks and queues with the help of linked list, and then we will jump on to priority queues later on, where priority queues can be done in 4 ways. I have already given the roadmap also. So that's all guys for this live stream. If you have not subscribed to our channel, I request you to please like, share and subscribe to my channel, and don't forget to press the bell icon so that you won't miss any future updates guys. I hope so that you have understood about what I wanted to explain, and there are no comments here in the chat, so we will be continuing, and I'll be seeing you guys in the next Saturday guys. So I hope so that this is very much clear. Every Saturday we are going to do some particular topic which is asked in placements, and this is your DSA placement live session. Well, I hope so. That's all for this video guys, this live session guys. Thank you for watching. I'll see you in the next Saturday, and till then take care. That's all. Thank you for watching Coders Arcade. This is Ashank David signing off. I'll see you